Okay, 12x fans, pre-calculus fans, we are looking at more with polynomials, but we're going to be focusing on the degree, complex roots, imaginary roots. Okay, imaginary roots are complex roots. Okay, so first of all, polynomials with real coefficients. Okay, so when we're dealing with this, the real coefficients, so in other words, the coefficients could be square root of 5, they could be 2/3, so any real number. Okay, so complex roots occur in pairs. Specifically, they come in conjugate pairs. That's a big word, conjugate pairs. So remember, a conjugate pair would be something like if you have a 2 plus 3i, then you're going to have a 2 minus 3i. Those are conjugate pairs. Okay, so if I have like a negative 6 plus I radical 5, then I'm going to have a negative 6 minus I radical 5. So conjugate pairs. Okay. If we have rational coefficients, so all of the coefficients are rational numbers, 5, -1, 2/3, stuff like that, then the irrational zeros or roots occur in conjugate pairs. Okay, so that could be like a 3 plus radical 5 and a 3 minus radical 5. Okay, or you do your quadratic formula and you come up with 2 plus or minus radical 7, something like that. So that's what they mean by the conjugate pairs. So now, if you see a 3 plus radical 5, you're going to see a 3 minus radical 5. All right, now, excuse me. All right, now we're going to do some polynomials work here. So we're going to find a polynomials with degree 3 with a given number of roots with rational coefficients. So we're going to be dealing with rational coefficients. Okay? So if I have 2/3 as a root, how do I write this out as a factor? Okay, hopefully you'll say 3x minus 2. Okay? And then you're going to say, if 5 is a root, then you're going to say x minus 5, and then x plus 1. Okay? Now, since we're in pre-calculus, I want us to write these out in polynomial form. Okay? So I'm going to multiply these together. You should be able to do that in your head. So it's x squared minus 4x minus 5. And now I just have to multiply this times this. Right now, I think it's easier when I multiply these two together, just use a box. So x squared, nice organizer. Doesn't take up a lot of room. And as long as you can multiply with exponents and variables, you'll be fine. So 3x to the third minus 12x squared minus 15x minus 2x squared plus 8x plus 10. So this polynomial is 3x to the third. Then combine those, so minus 14x squared. Combine those, minus 7x plus 10. There is your manynomial, your polynomial. All right. Oh, what the heck is this? Look at that, plus and minus 5i. How are we going to deal with that? Well, So if it's a plus 5i, then it came out as an x minus 5i. And if it's a minus 5i, then you write it as x plus 5i. So really, plus and minus 5i times x minus 2. All right, now, what do you notice about these? That's right, they're conjugate pairs. And when you multiply conjugate pairs together, something unique happens to the middle terms. Do you remember? That's right, they cancel out. So you would have x squared minus 25i squared. How come you didn't write the middles, Mr. Prada? Because they would cancel out. Okay? So x minus 5i, x plus 5i. There's your x squared. There's 5xi, negative 5xi. And then your negative 25i squared. Yes, right. Those cancel out. All right. Now, what do you remember about I squared? That's right. Where am I going to write that down? I squared is equal to negative 1. So this becomes, right here, this whole thing becomes plus 25. So we're looking at x squared plus 25. And now I have to multiply it by x minus 2. Okay? And you know what? Actually, we can, the way I have this set up, we'll just multiply it straight, just double distribute. So I have x squared times x. There's my x cubed. Then minus 2x squared. Then plus 25x minus 50. Or else do your box. All right, now here is the unique. 1 plus and minus 4i. So we're going to write as x minus 1 plus 4i, and then we're going to write it x minus 1 minus 4i. And you better ask, like, Mr. Prada, how the heck did we get that? I'm going to show you it right now. Give me a second, put this x plus 1. So there's the x plus 1 for that. Let me show you where this is coming from. Okay? It's not hard. It's just one of those things we just have to know how to do. All right? Remember what we did before. So it's x minus parentheses. And I'm going to do my 1 plus 4i. So notice I put minus with parentheses, and here's my other one, x minus parentheses 1 minus 4i. So now, what do I do with this minus sign? I have to distribute it. And what do I do with that minus sign? I distribute it. So there you go. There is your 1 minus 4i. There's your 1 plus 4i. Okay, it's just how things are written out. Okay, that's all. It's just how things are written out. All right, now watch this fancy math that we're going to do. Watch this fancy math. You see this x minus 1? And you see this x minus 1? You need to see those as one term. One big giant B. So right here, you have orange plus 4i, and then we have orange minus 4i. That's right, those are conjugate pairs. So you have x minus 1 squared minus 16i squared. I'll let you digest that. Orange plus 4i, orange minus 4i. Those are conjugate pairs. So this whole thing, okay, here I'll look at it on another sheet of paper. First of all, conjugate pairs. Remember, if I have a plus b times a minus b, those are conjugate pairs. And when you multiply those out, that's right, the middle terms cancel. Minus ab plus ab minus b squared. Those middle terms cancel. Okay? So when you're looking at this right here, when you're looking at x minus 1 plus 4i and then x minus 1 minus 4i, look at this and look at this as, I don't know, call it your favorite letter B, or B. So you're looking at b squared minus 16i squared. Okay? And then we just called b x minus 1, so that's how come I can just swap out the b and then squeeze in x minus 1. Okay? So that's what's going on there. Okay, so it's this times x plus 1. All right, so we have some cleaning up to do here. So x minus 1 squared, we've done that enough times now. That is x squared minus 2x plus 1. And then it's, that's right, what happens with negative 16i squared? This whole thing, that's right, that becomes plus 16. So now right here, I have x squared minus 2x plus 17 times the quantity x plus 1. And now I just have to, I'll do my box. Oop. So x plus 1, x squared minus 2x plus 17. There's x to the third minus 2x squared plus 17x. 1x squared, so x squared minus 2x plus 17. So combined, we have an x cubed minus 1x squared plus 15x plus 17. And we just multiplied, we just created the polynomial that has these roots. Technically, I should be writing this. Equals, I don't know, p of x. Actually, no, not equals p of x. Would be equal to 0. Equal to 0. Equal to 0. That's how we should be writing them out. All right. Last one. Uh-oh, 2 plus and minus. Radical 5. We're going to do the exact same setup with this. It's the exact same setup. Everything stays the same. So it's x minus 2 plus radical 5. And then it's x minus 2 minus radical 5 times x plus 3. Okay? And I can, this right here is just like I showed you here. All right, so now I'm going to do my highlight bit. For those of you that are visual learners. Okay? That's right. These are conjugate pairs. Orange plus radical 5, orange minus radical 5 are conjugate pairs. So then I have x minus 2 squared minus, what's radical 5 times radical 5? And hopefully you'll remember to just say 5. Okay. Then I have my x plus 3. We didn't do anything with that yet. You should be able to square that in your head. So we have, that's right, x squared minus 4x plus 4. Then we have to combine those. So it's x squared, let me slide this up, minus 4x minus 1 times the x plus 3. So I'm going to do a box for that. x plus 3, x squared minus 4x minus 1, and then filling it in. So 3x squared minus 12x minus 3. Boy, I'm going to have the smartest dog on the street with all this math going on. She's going to get higher grades than some of my students. Equals 0. There, we just did a whole bunch of creating the polynomials. Okay? I'll let you digest that. Think about how my dog is going to be smarter than you with all this math that she's paying attention to. All right, I'm going to flip the paper over now. Okay, so now we're going to find a polynomial function of degree 4. So degree 4 means how many roots. That's right, we're just going to have 4 roots with negative 2 as a 0. So what does that mean, negative 2 as a 0? That's right, that's a root of multiplicity 1. Oh, wait, what does multiplicity 1 mean? Multiplicity 1. Well, that just means negative 2 shows once. Negative 2 shows once. 3 is a 0 of multiplicity 2. Well, what does multiplicity 2 mean? That means 3 shows twice. And negative 1 as a 0, multiplicity 1. So that means negative 1 shows once. I'm just going to do this and I'm just going to leave this answer in factored form. Okay? So, how do I write this as a factor now? That's right, that's x plus 2. And then, how do I write this as a factor? Pair of 3s. That's right, that's going to become, I'm going to put it in front. It doesn't matter. I'll put it in front. So it's x minus 3 squared. And then this becomes x plus 1. I'm going to leave my answer like that. We don't need to multiply this out. Okay? We're going to leave it in factored form. And because it says find a polynomial function, all right, I'm going to pick my favorite letter P for polynomial. There. All right, now the last one. The last one goes with those definitions that we had in front. Remember those definitions? A polynomial real coefficients, complex roots occur in conjugate pairs. Polynomials with rational coefficients, irrational zeros occur in conjugate pairs. Okay? Oh, and by the way, what do you know about real numbers versus rational numbers? All right. Real numbers include your pi's, your e, okay, your decimals that are non-repeating, non-terminating. Your square roots of non-perfect squares are all considered irrational. So the real is a mixture of your rationals, fractions and decimals decimals that can be written as fractions, and irrationals. So that's the reals. That's the real number system. All right, now, so a polynomial function of degree 5. So it has to have a degree 5. So degree 5 means how many roots? That's right, 5 zeros. With rational coefficients has the given number of zeros. Find the other 2 zeros. So 3/4 is just 3/4. There's no buddy for it. But what do we know about negative radical 2? That's an irrational answer. And so if I see negative radical 2, who else am I supposed to see? That's right, we're supposed to see a positive radical 2. And now here's a complex one. If I see 1 plus 2i, what else am I supposed to see? That's right, I'm supposed to see the buddy 1 minus 2i. So if you see 1 plus 2i, we got to see 1 minus 2i. If we see negative radical 2, And then we have to see a positive radical 2. Remember from the quadratic formula, you have your plus and minus? Well, there it is, plus and minus. All right, here we go. 5 is an integer value or a rational value, so nothing fancy. But here's your irrational. So if I see 3 plus radical 2, what else am I supposed to see? That's right, 3 minus 2 radical 5. And if I see 4 minus I radical 2, what else am I supposed to see? That's right, 4 plus I radical 2. Those are your conjugate pairs. So 3 minus 2 radical 5, and then 4 plus I radical 2. Okay. All right, now this one's degree 6. Well, I made it degree 6 just so we had a little bit more work to do, that's all. So here's a positive radical 5. Who else am I supposed to see? That's right, a negative radical 5. If that's 2 plus radical 3, what else am I supposed to see? That's right, the minus version. And if I see negative 5 plus 3i, that's right, just change, all you do, you know, touch this number, the only thing changes that. So we're also supposed to see the minus. Okay, so we have a negative radical 5. We have a 2 minus radical 3. Minus radical 3. And then negative 5 minus 3i. All right, any questions? Ella will answer them. All right, you guys have a good day.